So, so today we'll discuss about the types of RFCs. So normally we know RFC. What is mean by RFC? Remote function call. So what is the advantage? What is the use of this RFC? So this RFC is kind of one mechanism. So to allow business applications to communicate and exchange information with the other systems. Exchange the information with other systems. We will use the RFC, right? So RFC, suppose like example, you have the ECC system, you have the one sales system or a banking server. So you want to send the data from this system to this system, you need to establish the RFC. RFC connection you have to establish. So exchanging the information with the other systems, right? So exchanging the other information here, right? So here we will use the RFC destinations. We have to use it so that we can transfer the data, whatever it may be, whatever the data from one system to other systems, we can transfer it here using the RFC call here. So RFC is a standard SAP protocol here to handle the communication between systems. Communication between systems, we can use the RFC here, right? So here SAP uses the CPIC protocol, CPIC communication method, CPIC. So CPIC communication method, CPIC, Common Programming Interface for Communication Protocol. It will use the CPIC protocol to transfer the data between the systems. So what protocol it will use it here? To log into your banking site, HTTP or HTTPS protocol, you will use it. But system to system to transfer the data, SAP to SAP, SAP uses the CPIC protocol to transfer the data between systems. It is a SAP specific protocol. SAP specific protocol here. SAP specific protocol to transfer the data here, right? So here the RFC, this RFC connection will help reduce the efforts of programmers, right? Why? Because this RFC connection, it will help reduce the efforts of programming here, right? Why? Because they have done the development activities in the one system, they want to do the quality, then how they can transfer it here, right? Through RFC data, they can transfer the data. Means it will reduce the, reduce the developments activities, everything here. Also, this RFC convert the data into format, understandable format by the remote system. Your remote system is a different format, then it will transfer, it will convert the data into understandable language, understandable format here. Also, also securely in the network, it will transfer the data from one system to another system. That is what we know about the RFC. The same concept here, there are the types of RFCs are there. So types of RFCs means SM59. We see like there are the above to above connection, R3 connection, HTTP connection. Those are the types of RFCs, right? No, those are the RFC connection types. Those are the RFC connection type, and types of RFCs means these methods they will use it here. There are the 4 types of RFCs are there here. RFC types here. One is the synchronous RFC. One is the synchronous RFC here. Types of RFCs are 4 here. One is the synchronous RFC here. Synchronous RFC here, right? Sync RFC, synchronous RFC. Normally we will call it as the synchronous RFC here. Then second one is the asynchronous RFC here. The third one is called the transactional RFC here. Transactional RFC, transactional. So RFC here, right? TRFC. Normally we will call it as the TRFC here. The fourth one is called the queued RFC here. So queued RFC here, right? So queued RFC. There are the 4 types of RFCs are there here, right? Synchronous RFC, asynchronous RFC, then transactional RFC, then queued RFC here. Queued RFC here. So when this types will be used, when these types will be used, right? So let's start discussing about the one by one here. Then you will come to know when it will be used here, right? So these two will be used internally. There is no specific transaction code for the sync and asynchronous RFC here, right? So sync RFC means here it requires both the systems. Suppose you are sending the data from here to here, right? Then while sending the data here, the target system should be also available. Should be both the systems, client and server should be available at the time of communication. Why? Because this is the client. Example, the client is sending the communication to the server, right? So otherwise, this is the client. This is sending the communication to the sending the data to the here, right? So at the same time, both the systems are should be available here to transfer the data. So both the should be available here. So this is the most common type. It is required immediate results or immediately data transfer, immediate execution. We will use it here. The communication between both the systems. Then there is a acknowledgement is required. The acknowledgement is required means for the data consistency purpose via this communication method, system will accept the acknowledgement here. So suppose if the issue is if the target system is not available, source system resources will wait until target system available. So source system is waiting, right? This may lead to the source system gone to the sleep mode or RFC or some CPIC mode turning. Hence, why? Because it will block the some resources here. Example, when you're transferring the data to target system here, but target system is not available, it's down. Then in this case, source system will keep on waiting, will hold, will waiting, will hold for some time. Then it may go to the sleep status or some other status, it will go to the here, which means so source will not send the another data. Why? Because until first it will send the some data to here, then it will receive the it will send the acknowledgement back to the main system here sending that. So then source will send the second data, it will send the acknowledgement back. So means suppose in the old mobile phones, not the smartphones, we have the option when you send the text message to your friend, you will get the acknowledgement delivered, something like that. You will get the acknowledgement, which means your message has been successfully delivered to your friend, right? So then that time, so you will get the delivered option. Nowadays, we are not sure whether it's delivered or not. We are not received any acknowledgement also here. Just you are keep on typing. After some days, after some time, then it say that not sent, something like that. You will get the message, but immediately you will not get the delivered, something like that message here. But not sure in the latest mobile features. But in the old mobiles, we have the option. When you send the text message to your friend phone, then you will get the thing. There is one ringtone, you will get one beep, you will get like that delivered, something like that. Acknowledgement you will get, right? So which means when source is sending the data to the target, then once the target is received, it will send the acknowledgement back to the target source saying that I received your first transaction, then send the acknowledgement. Then the source will send the second transaction to the here. Then it will receive it, then it will send the acknowledgement back to the here. So which means this both the communication process, both the systems should be available. Both the systems should be available here, right? So that is the communication between the systems. It will use it here. But there is a asynchronous RFC. Asynchronous RFC means the communication between systems where acknowledgements are not required. So sync means acknowledgements are required here. So async means acknowledgements are not required here. Opposite to the sync here, which means so it is similar to the postcard delivery, right? So synchronous means definitely acknowledgement is required. So they will take the acknowledgement, everything. But asynchronous means the postcard. When you are sending the postcard to your friend, not sure whether your friend received or not, but you are sending to the postcard, no acknowledgement is required. That is kind of postcard here. right? So this communication between where acknowledgements are not required. It does not require both the systems to be available at the time of execution. The target down also, if this system is down also, this system is down also, there is no worry here. It will wait, it will not wait for the acknowledgement, it will keep on sending the data to the target system here. But this is not the reliable communication, since data may be lost if the target system is not available, right? So why? Because asynchronous, synchronous, there are both are difference. So here target is available, then only it will send the data. Then in this case, so reliable data, there is a reliability of the data to receive the data here, right? But here there is no acknowledgement is required in the asynchronous protocol, but asynchronous protocol, there is no acknowledgement here. It will not receive any data. The target is not available also, it will keep on sending the data. But because it does not require any acknowledgement for the second transaction. So it's not the reliable communication method here. So this will be used internally. Internally, system will use us in the depends upon the method. System will use internally. We don't have any transaction code. Just to theoretically, we can say we have the 4 types of RFCs in that sync and asynchronous. So this is the differences here. Where sync is acknowledgement is required. This is reliable for the communication between source and target. It will wait for the acknowledgement of the to send the second transaction. But asynchronous, nothing is required. Even target down also, you can send the data, but whether not sure whether target is received or not, there is no need to bother about the targets received or not. That is called the async RFC, right? So then transactional and queued RFC have the some transaction codes to track it here. Transactional RFC here, normally we will call it as the TRFC. Transactional RFC, normally we will call it as the TRFC, transactional RFC here. It is a special transactional RFC. It kind of handling of the steps, original steps here, steps. So which means, so the transactional RFC is an asynchronous communication method. Asynchronous communication method, same as like asynchronous only, transactional RFC. But here, for each and every transaction, when sending to the target, it will assign the one transaction ID. So one transaction ID will be assigned to the each and every TID. That normally we will call it as the TID. It will assign the TID, transactional ID, to the your data, corresponding data here. Unique to transaction ID will be assigned. So that what will happen? So even the target is down also, that data stuck here, but each data there is a transactional ID. So in this way, there is no duplicate data should not be processed to the target system here. So series wise, it will send the data because of the transaction. There is no duplicates. There is no duplicates of the data. Normally, we will call it as the transactional RFC is the extension of the asynchronous RFC, secure communication. This is one kind of a secure communication between systems here. The transaction code to monitor this one is the SM58 is the transaction code to monitor the transactional RFCs and everything here. If we go to the SM58 transaction here, we can monitor here. We can monitor, are there any transactional? This is one of the daily monitoring activity. We can check, are there any transactions are stuck or not here, right? Let me remove the dates and see. So here we can see any transactions got stuck in the system or not. It will give you the information, right? It will give you the information to send the data here. That is called the transactional RFC here, transactional RFC. So here in SM58, we can monitor and we can check it out. So as part of the daily monitoring, we need to go to the SM58 transaction code, check, are there any failed transactions here? Who is the caller? Caller means who is the user here, right? So what is the target system? It got failed here. So those things we can check it out here. Those things we can check in the systems here. Who is the user? Who is the caller? So what's happened in the systems? Why these transactions got stuck? So it will give you the information here, right? So each and every transaction, there is a transaction ID is assigned. In this way, there is no duplicates. There is no duplicates of the data here. There is no duplicates of the data here, right? So when the target is as soon as target means target system. So which means target system means this is the RFC destination. It will use it for the target destinations here. RFC destination, it will use it for target. RFC destination, it will use for the target system here, right? RFC destination, it will use for the target system here, right? So there is no duplicates of the data to transfer the data, right? There is no duplicates to transfer the data here, right? So in this way, so communication methods will be used here. Communication, so methods will be used here to transfer the data in the systems here. Data in the systems here, right? So RFC communication to transfer the data, it will use the communication. RFC destination, it will be used it. So if you are sending the data to the target means because of the RFC destination here. Because of the RFC destination, you are sending the data to the target here, right? RFC destination here, right? Suppose in case if the data got stuck here, we can reprocess. We can select it. There is a we can reprocess here, reprocess the data here, reprocess the data, execute LUW, something like that. We can execute it here. LUW, we can execute it here. So that this data will process here. This data will process to the target, means this data will go and sit into the target system here. So that type of communication will happen in the systems here, right? So you can just execute the transaction here. You go to the here, execute, you can execute it here, execute it, you can do that one here, right? The target system, we can do that one. So only thing is you should have connected to the target systems here. Target system means either your ECC or BW or whatever the data you are transferring from this system to that system. So those systems you need to create as a RFC destination. You need to transfer the data. You need to transfer the data here. That's what we required here. Okay. See here today's date, the data got failed. User switch is not possible because of the different color. So this data, the post data, the EBP post data is not transferring to the target system here. So in this case, in case of it's not our issue, something is wrong, then you are trying to reprocess, even though it's failing, means you need to inform to the your functional folks, functional team. Why? Because so they can check the data, whether this data is correct or not, they can validate it. But because functional team is responsible for the data validations and everything. If any technical issues like connection failed, system is down, RFC destinations are not working, so then we are the responsible. We can check it out. So it's working fine. So nothing issue in the system. Then we can say like, we can check, we can ask them to investigate the issue from their end and everything. We can check it out here. We can check it out all those things here, right? So here, so let me change the connection to the ECD system here. So I'm changing the connection to the ECD, ECP to ECD connection test. I have checked it here. Okay, so here what we can do if we want to reprocess. So here reorganize means deletion of these things. Sometimes they will tell like please delete this entries is not required. Then we can delete it. So we can reset. Sometimes what happens instead of reprocessing, just if you do the reset of the function, you do the reset. Reset means the status will be reset to the original. So original status here. Then that time this data will be processed. That time this data will be processed here, right? So that's our duty is reprocessing or deletion or informing to the functional team. In case of if any data stuck, we have to inform to the functional team here. We have to inform to the functional team here. See here, to reset the status, the transaction got recorded here. Transaction got recorded here. So what is the transaction ID here? So this is the transaction ID 21 here, right? So last digits is the 21. Try to refresh whether we are able to progress or not here. So that if you are able to progress here, then data is successfully moving to the target system. Like that, we can assume it here. The finance data is moving to the target system here. So there they will do the some adjustments and everything. Again, it will go to the some other banking server. some other banking servers. So like that, it will process it here. Like that, it will go to the processing status here, processing status here. So transaction is recording. So then you can try to re-execute also. You can try to re-execute also here. So with today's date, so what we are trying? We are trying to reprocess these transactions via RFC destinations. So if the data is going outside of your system, means that is the target system. Target system, it is transferring here. See, target transactions recorded. So again, it got failed. User switch is not possible, right? User switch is not possible here. So like that, suppose let's see this transaction RFC destination having some errors here. Let's try to reprocess this transaction as well here. So just try to do that one here. Let's see what will happen. This is also user switch is not possible. Why? Because I am logging with the basis user, then I am progressing the this caller related data. So that's not possible actually. So it's not possible. But we tried. So to change the date and entries, we tried here. So the entries are created here. So transactional RFC means even though the target is not available, source system can send the data, can try to send the data. We can see that the transactions and everything, we can see it here, how many transactions are failed and all those entries we can see it in the, so SM58 is the transaction code. There we can check the all the information and everything, we can check it out here. All the information we can check here. That is the, so transactional RFC in SM58 we can see it here. Sir, who will do this kind of configurations and everything? Means functional team will do the configuration. Technically we need to check whether the system is available or not here. So transactional RFC is a extension of the synchronous RFC. So but here only the difference is here it will assign the one transaction ID to avoid the duplicates data in the target system. So why? Because here if you send the multiple times, what will happen? If the same data is available, then it will say like duplicate data. Why? Because that data is already available in the target system. So it won't send the data here. Why? Because so here based upon the transaction ID, the data got stuck. If the similar data available in the target system side, it won't send it out because of the data already exists, duplicate data. So to avoid the duplicate data, duplicate processing and everything, so the transaction will stuck here itself only. The transaction stuck here in the here itself only here. That's the, so thing of the transactional RFC. Our duty is we need to check in the last 24 hours or last 48 hours. If any transactions got stuck, then we can progress the transactions and everything. We can progress it here by changing the target system details and everything. We can change it here by, we can change the details and everything here, right? That is the transaction RFC. The next one is the queued RFC. Queued RFC here. This is the kind of important step here. Queued RFC here. Queued. So for transactional RFC, we have the transaction code SM58 we can monitor. But this too, we don't have any transaction codes. Queued RFC also we have the transaction code here. So what is mean by queued RFC here? Queued. Queued RFC means as a queue. Queue means order, sequence, right? When you are onboarding the bus or flight, so we have to queue wise, we have to go, like we have to onboard it, we have to go and sit it out queues. So please follow the queue, right? Queue means sequence wise, order wise, right? It will transfer. So same as like the queued RFC means when you are transferring the data to source to target, so just queue wise, order wise, sequence wise, it will transfer the data to the target system. Source will receive the data into the queues wise. So here, so queues means we have the two types of queues here, inbound queues and outbound queues here. Outbound queues and inbound queues here. Inbound queues and outbound queues here, right? Outbound queues and inbound queues here. So outbound means which are going outside of the system, right? Inbound means which is coming inside of the system. Inbound, outbound, and inbound queues here. So queues means order-wise it will transfer the data in the sequence via queues. It will transfer the data here via queues. It will transfer the data here, right? So here it will ensures that individual steps are processed in a sequence. In a sequence here there are the multiple individual steps are will go via sequence wise individual steps are executed. Suppose if one transaction is required the individual steps, like not bulk steps, all the steps, so just one by one we have to execute it. Some transactions are sequence wise, we have to execute it, some data. In that case they have to go for the queued RFC here, right? Queued RFC, individual steps are processed in a sequence wise here. So this will guarantee that multiple transactions are processed in order, in a sequence. The application, whatever the specified application order, it will go order wise, it will transfer the data here. That's why we have the, so inbound and outbound queues are available in the system here. Inbound and outbound queues are available in the systems here. So suppose inbound queues, SM, so SMQ2, out inbound queues, right? In SMQ2 queues, we can check it out. Are there any queue entries got stuck in the system or not? Yes, there the some entries got stuck in the systems here. What are those some entries here? Right? So there the some entries got stopped and stuck in the systems here, right? Entries got stopped, stuck in the three entries got stuck. These are the queues. So they are the queues here, XB star queues and star BQ are queues here. Queues we can see it here. Inbound, which is coming inside of the system here, right? SMQ1, right? SMQ1 here, SMQ1 here, sorry, SMQ2 here, inbound queues, right? So outbound queues here, SMQ1 here we can check the SMQ1 here, SMQ1 here we can check the outbound queues here, outbound queues, SMQ1 here, right? So here we can check the what is the data got stuck here, how much data got stuck here, right? Here we can check the all the data here, all the data we can stick it out here, how many queue entries and what got stuck here, right? Which is going out means via RFC destination only. See here, this is the RFC destination. So this is the RFC destination which is pointing here. This is the RFC destination which is going outside of the system here. See, lot of data, HR data got stuck here, right? Which is going outside of the system here. So these queues all got stuck here, right? So we need to check if it's got failed. So via RFC destination, this is getting failed. So we need to check what is the status of the RFC destinations here, right? So if you go to the SM59 transaction code here, so we need to check the RFC destinations here, right? One is the, suppose like there is a RFC destination. What is that? So this is the one, right? This is the one RFC destination, B3T CLNT 800, B3T, B3, no, that RFC destination even not exist. So B3T, right? B3T. So this destination is not exist here. Then how this will send the data to the target, right? We cannot send the data to the target system here, right? So we can create it. We can create this data here. We can create the destination here, right? We can create it here. So because of these destinations are not exist, so we can create it here. We can create these destinations here. We can create these destinations. So like we have the one system is available here, one ECC system. So those ECC systems we can give those ECC system details. Client is 100 client, user is the basis. Then let's try to give this one here. Let's see what will happen. Right? So destination we created, right? Destination we created here, right? So now it's connected to the destination. Even destination is not exist. That's why it's got failed. Any entries got failed. Suppose let's see here. This is going to the this destination here, right? So these entries are going to this destination. When it got filled 2018, this got failed. So we can re-execute it here. We can re-execute it. We can execute the status here. Execute LUW, right? So LUW here. It will be failed here. It will be failed. So this is the queues. Via queues, this data will go to the target system here. Via queues, this data will go to the target system here, right? Queues, outbound queues and inbound queues. So outbound queues which are going outside of the system. How it will go to the outside of the system? Via RFC destination. Via RFC destination, it will go to the target system here. It will go to the target system here, right? So same, let's create. So like that, we need to check and we need to fix the issues here. We need to check and we need to fix the issues here. We need to check and we need to fix the issues here. So then there is a click RFC also I created here. Click RFC. There is a click RFC also I created here. Right? So via this destinations data will go to the target system here. So why? Because in ECC, the data is getting generated. In ECC, the data is getting generated here. See, so previously, okay, let me remove that. So we have these entries are exist here, which is coming inside of the system here, which is the queues got stopped status here. So which is going out, then SMQ1 outbound queues here. So we need to check, are there any outbound queues got stuck in the system or not? We need to check it out here, outbound. So waiting status. So then what we have to do as part of here, just to execute, we have to so reset the status, or we can execute it here. We can execute it here. We can execute the status here. But it is going to the target system. Target system, it is going here, right? So what we can do, we can activate or we can execute the status here as been further procedures. So this has in some further procedures here. So normally if anything stuck here, you need to inform to the respective functional team only. But our duty is check the status here. If something got stuck, we have to inform to the respective functional team here, So via this RFC, the data flow will happen. Via this RFC, the data will happen into the target system here, the target systems here. That's what will happen in the systems here. Okay. So that is the, sir, where can we create the queues here? Right? Where can we create the queues here? SMQ1, SMQ2 is the transaction code for the to monitor the queues. If any entries got stuck, which is going outside of the entries, which is coming entries, we can check it out. That is fine. Inbound queues and sir, I want to define the queues. Where to check the queues and everything. For checking the queues here, we can use the SMQR. SMQR inbound scheduler, queue in scheduler, right? SMQR means inbound scheduler, which is coming inbound scheduler, inbound queues, inbound scheduler here. Here we can define the queues here. Here we can define the queues, which order you need to transfer the data. We can define the queues here. This way we can transfer the data here. Normally this should be the inactive status here due to the some resource error, I think, which is failing, which is resource error. Let me check what is that. We can activate the scheduler here. So there is a error here. CIF queues. See here, lot of queues are there. We can also create the queues here based upon the XB star queues. So then we can also create the queues here. We can also to create the XC star. Normally they will ask us to create the queues via this way. So then we can create the XB star, XC star queues, XC star queues, right? Then click on the create. So then XD, AB star. So then functional team will request us to create it here. The naming convention also they will request to us to create it here. So then we will create the star, which means the queue order wise it will go to the in this queue here. So functional team will develop this queues, then it will go to via this queues, the data will go here, right? This is the SMQR. If we go to the SMQS, outbound queues which are going out, right? SMQS QS, outbound queues here. Means, suppose if you want to transfer the newly created system, you want to transfer the data, then we can create the destination here. So click on the create. Then what is the destination? Suppose like we had a ECC, right? Yeah, the ECC systems are there here. Let's see what is the ECD. We have the ECD connection is there here. Then I want to transfer the data to the ECD. Then ECD connection I created here. Then I can transfer the data to the ECD system. ECD system, I can transfer the data via these destinations. I can transfer the data to the ECD systems here, right? So this way we can create the creations, the configurations, we can define it here, right? So the destinations configurations, the queues configurations, we can define in the SMQR and SMQS transaction code here. As this transaction codes, we can define it here. We can define it here. So in case of any issues, what we can do here, two actions we can do it. So in case of if any entries got stuck in the SMQ1 and SMQ2, we will try to activate the scheduler. We will try to activate the scheduler here. It will try to activate the scheduler here. Actually, it should be the inactive status here. Inactive status here. If not inactive status here, something there is a problem here. So we need to resource error. Resource as means there are some resources, means the work process or something is not available. That's why it's giving the resource error here, right? So if you want to delete the entries, you can delete it here. So that's we can do it. What are the entries we have deleted, have created? Last time we created, that's why it's giving the errors. Resource error. RFC resources. Resources are not okay. Okay, that's the problem here, right? Resources are not okay. Resources means dialog or the process are not okay. So it is using the what is the destination, what is the group here, default group it is using here, right? Default group means in SMLG, what is the group it is configured. So there is no default group here, right? Now RJ12, what is the group here? Here also there is no default groups here. So what we can do, so we can remove the groups here, right? There is a default group it is referring, there is no groups here, right? There is no change groups here. There is no groups here. Just remove the groups here. Just to remove the groups here. So what I can do, otherwise we can create the group here in RG12. So RJ12 is for the groups creation here, groups, RFC server groups here. So which means multiple application servers will process via this groups here, this groups here. So default group, then we can assign the instance. Okay. Okay, so default group we created. So RFC server groups here, which means normally logon groups is for the logon groups for login to the SAP system via groups we can log in. But RFC to RFC, you have the multiple application servers in one system. But you are pointing to the one application servers only. In that case, we can use the RFC server groups, we can use it. So via these groups, the data transfer will happen. Via these groups, the data transfer will happen into the systems here, right? So that is the one thing here. So via this group, the data transfer will happen here. So it's on. So that is the reason here. So we can see, so we have to configure the groups here. So we need to see what is the, so number of logons, so number of work process, minimum number of work process should be required. So here you have the details here, all the details we can see, maximum number of work process will be used here, right? So how many we have to use it, how many should be minimum, maximum, there is a, so count is there here. So those count we can check it out here, right? So that is the inbound and outbound queues here. So SMQR, SMQS, we can do the configuration. We can perform the configuration of the system, configuration of the queues and outbound queues here. So which means, so this is the one system here. Then this is the one system here. Suppose if you want to send the data to here, then from ECC to here, this is called the outbound queue. This is called, each system there is a queues, inbound queues and outbound queues here. In each system there is a inbound queues, there is a outbound queues here. So what will happen? This is a one system, this is a one system here. So when you are transferring this one, this is the out, which is going out, right? Then via this out to via this in, data will come to inside of the database level. It will insert the records into the table level, then which is going out, then outside to again out. Out means via RFC destination, it will via RFC destination, again it will connect to the via RFC destination, again it will connect to the this system here, right? So here it will insert the some records here, then data flow will happen. It will insert the data into the here. So this is called the outbound, which is going out. This is called the inbound, which is coming in. While data is coming to inside system here, there should be a proper order we have to follow. Proper order we have to follow, right? So that order will come via queues. That's why we have the queues here. That's why we have the queues here, inbound queues and outbound queues here. So we have the queues here. Via queues, the data transfer will happen here. Via queues, the data transfer will happen. Seems that the 3 entries got processed, right? You see all the entries. Previously, there are the 3 entries got stuck. Yeah, still stuck here. Yeah, star. If I maintain the star, it is coming here. If it got stuck here, the queue got stuck, stop. The queue got stopped status here. So we can unlock the queue. We can unlock the queue. Then it will go. Data will go here. Unlock the queue. Data will go here. No LUW found in the queue. So there is no data. That's why it's not sending any data here. All right. So then SMQ2, SMQ2, inbound queues, sorry, SMQ1, SMQ1, outbound queues here, out, which are going outside of the systems here. So you can see outside means via RFC destination only it will connect it, right? If you want to transfer the data to this system via RFC destination, then RFC SM59 we created the RFC destination. Then via this RFC destination, it will transfer the data to the this system here. When it comes to this system, there is a queue. Via queues, it will come to inside of the system. Then when it is going to out via data, it will send to the here. So like that, the data flow will happen. The data flow will happen from one system to another system via queues here. These queues are, so sir, where can we check actual data is processing or not? This is why, because we are not only one system in the market. We have the n number of systems and n number of business servers are there. Server to server communication, it will use the RFC destinations. So something data flow is not processing, data flow not happening means, then definitely there is a issue. You are transferring, you are sending the data to the one of your friend, sorry, one of the banking, you are doing the some transaction, you are trying to book the one movie ticket, right? Or you selected the seat and you are booked the ticket, then it will go to the payment, you are doing the payment, it will go to the banking server again. From your server to, it will navigate to the external side banking server. Then banking server will, once the transaction is done, banking server will send the acknowledgement back to the your main server saying that I received the transaction, you can go ahead and book the ticket. Then your ticket has been booked here, right? So that will happen in the, so in the back end, it will happen like this here. So means acknowledgement, receiving the transaction, connection to the banking servers and everything will happen via queues, RFC destinations, it will happen here. Okay, this is the RFC types of RFCs here. Okay, any questions?